here. So this week, what I kind of think we're going to do is we're going to start off by just kind of covering the weekly topic, which this week is indexes and constraints, which is actually a pretty fun topic. I think it's fun because it has like a lot of like historical and I guess easier to understand context, which is kind of fun. And then what I thought we could do after we cover kind of those two a little bit quicker, I actually have started, I guess I prepared a little bit because what I'd like to do for those of you working on finals and for those of you, even if you're not, I thought it would be fun to kind of get a little bit of an insight or kind of see what it would look like if we were going to actually make this work, or if we were going to kind of put together an API and or run a web page from our database. So what I thought I'd do is I just build like a quick little website that uses some of our data from Sql. And I actually kind of have it set up to where for any of you guys who want to kind of follow along a little bit, we can. I also I have a Git repository that kind of has like a starting point, and then I haven't done much past that. So it may be a little tedious to watch, but I think it'll be insightful because we'll kind of see it all kind of happen as we go. But anyways, with that being said, let's dive into our content for the week, which is our indexes and constraints. So just to kind of, I guess, restate slightly what I put in the weekly announcements, indexes are these things that let us, that let the database work a little quicker. I apologize, for some reason, Canvas isn't loading for me. I don't know if anyone else is having those issues, but there it goes. Anyways, so indexes let the database do things quicker, and we kind of use, I guess, our human brains to kind of help it work through, what can we do to make things faster. And the example that I like to use all the time is email addresses, because more and more, like, you build your account based on email addresses, and they're important because, I forgot my password. Well, shoot it to your email address, a password reset link. So more and more systems are using your email address as kind of like your unique identifier, which I concur with, and have done so myself. It just makes sense. But the key to that, why we can do that, is because we expect, or we assume, that every email address should be unique. We're not going to let two users with the same email address sign up, because A, that could be problematic on the basis of security, and C, it could, and B, there'd be duplicates. So what we do is we can create indexes to make it so that not only works faster, but also constraints. So that's why these two kind of go hand in hand, because we also have constraints to make it so we can put constraints on our data to make sure that we don't have duplicates. We don't have anything that's going to be problematic. And the reason why we put it in the database layer is because it's very strictly enforced. We don't have to like do a lot of stuff. Like, it'll just kind of take care of it for us. But as with on all things, there is a downside, as you'll probably come to find or have already found from the reading. So just real quick, I'm just going to pull open some PowerPoints here, our PowerPoint, because I think it'll have some good examples. So like we talked about, our index can use to find things. Now, I guess real quick, to kind of put an index into easier to understand terms, I always like to liken it to a library, right? The library is where we go and actually get books, which is pretty rare these days. But you can imagine if you go into a library and you are seeking a single book. Now, in libraries, they structure libraries to help it make sense, which is somewhat of an index itself, right? Like if we go into Barnes and Noble looking for that one Brandon Sanderson book that we're dying to read, odds are we're going to be able to find it based on, markers in the aisle, or in other words, an index. And so what we can do is we can kind of use we can kind of use that some logic, some business logic to help us create a faster way for the database to do things. So for example, if we want to index our library by the author's name, we can do so. You can imagine if you just walked into a library or Barnes and Noble looking for that one book and there were no markers, the books are just sporadically sourced everywhere. Like our database, because in a database, data just is organized in the manner in which it comes. So, in this case, it's like Barnes and Noble would have their books ordered by the time that the books came into the store, which would be all over the place. That's how our database is. So you can imagine if you walked into that and you were looking for one book, basically the only way to find that book is to literally start at aisle 1 and check every book. If there's no index, well, that's where our indexes come in. So databases work in a very similar manner, in the sense that if we don't have them, that's exactly what the database is going to do. It's going to, if we're looking for where the last name's equal to Sanderson, it's going to start at record 1 and it's going to go all the way through. And if it finds a Sanderson, it's going to pull those out and kind of say, oh, I'll put this in the list, and then display them to the user once I get through all the records. And you can imagine if we have 1 million records, like if we're, big, that can take a lot of server resources, because when it's doing that, all those records eventually make it into memory of some sort. So indexes can be very vital, because let's say we build an index on the author last name column. It'll be able to go and say, hey, I know that S's start at record, 10,000. So instead of going through every record, I'm just going to start at record 10,000, because that's where the S's start. And in this case, Sanderson is SA. So, depending on that, it'll use logic to basically find those records faster. And what's nice is, because it's indexed, it knows, oh, if I get to where the S's stop, where it no longer starts with the letter S, then I'm done, because Sanderson can't be past R, because I've organized every record by alphabetically. So that's where the indexes come in. They help us do things really quickly. And it'll talk through that. Index creation. I'm not going to spend a lot of time at this because they're pretty easy, but we can add indexes to existing tables, or we can create indexes kind of standalone. Let's keep going. We can drop indexes. Okay, so unique indexes. This is where we were talking about with the email, and this is the exact example they use. They add an email, not only an index, but a unique index. And what that does is it makes it so not only can we find records real fast based on the email address, but there can only be one email address. And the reason these go hand in hand is because, like, let's say we're looking for, Bilbo Baggins at theshire.com. If it's a unique index, as soon as it finds that email address, it can stop looking, because it knows only one can exist. Now, if it's not a unique index, it has to continue searching through the rest of the data, which, again, takes time. Where if it's unique, it can only do that. And if it's a unique index, there's automatically a unique constraint, which means if I try to insert another customer with the email Bilbo Baggins at theshire.com, it will fail. It'll say, hey, you can't do this. We already have a user with that email, which is good, because you can imagine if we had 2 users with the same email and someone did a password reset, 2 people would get the password reset, and that could be problematic. You can build indexes on multiple columns. There's a few different type of indexes. And just real quick, there's a B tree, bitmap, and text. And we're going to talk a little bit about this. So B tree indexes are good for when they're balanced. So they use the alphabet as a good example. Because going back to our Sanderson, we could quickly narrow down the amount of records that we need to search by saying, hey, I'm looking for S. Okay, that's in this set of records. And furthermore, if I can narrow it down to this subset. So like if we had 10 million records, I could maybe narrow this down to a very small sample of like, let's say 100,000. B-tree indexes are best for categorized data. So in this case, we're categorizing by the alphabet. So categorize, meaning that like it's, anyways, I think it'll make more sense when we look at here. So, and it says it right here, actually, B-tree indexes are great when working with columns with many different values, but are harder to work with when a column only has a few limited options. So B-tree works good when we're like categorizing, but there's a lot of different options. As you can see, there's 26 letters in the alphabet. However, a bitmap is better when there's few records. So in this case, it uses the active flag, which is a 1 and a 0, and it uses that as a bitmap, meaning that it can find it. And there's some really cool videos where they actually like visually explain like the bitmap stuff. It's really cool how that works. But just know that B-tree is for like categories, many categories. Bitmap is best for like small options like male, female, yes, no, on, off, those kinds of things. Text indexes. Text indexes are great for obviously full text, which these are the least efficient, but they are obviously necessary. Okay. So the downside of indexes. The downside of indexes is anytime we create an index, the database is going to kind of like create this metadata. So for example, going back to our author and our library, it's going to create its own tables, its own database kind of information that says, hey, if I'm looking for SA starting last name, I'm going to, those can be in records here to here. It creates all this metadata. And so when we create, because, these indexes can improve the database. So let's just index everything. That's the wrong answer, because when we create an index, it creates a little bit of overhead. And this means extra disk space. And also whenever we manipulate our data, it has to maintain all this. So just keep in mind that as we add an index, it creates a little bit of overhead. Now, most of the time, if you're being smart about it and think like, oh, this is a column I'm going to use a lot to query, and it'll really help narrow things down because it's like a good segment, like add it because it's really good. But however, anything that's not used frequently, like we don't want to do because it's going to create that overhead and the optimization isn't worth the cost. All right. Constraints, there's quite a few constraints, but these ones are all usually ones that we've seen before. The only new one might be this check constraint, which is basically an open-ended, like you can build your own rules kind of a thing. So for example, if we have like a column that says, do you opt into text messages, and yes or no, we can check to make sure that it's the values can only be yes or no. You can't type in maybe, you know what I mean? Like everyone has to be yes or no, so to speak. All right. There's a few details like I don't want to spend too much time on. Cascades. All right, and we've talked a little bit about those before, so we'll leave that. Okay, any questions about indexes or constraints before we move on?
I kind of have one as it relates to the final project. should we have those constraints on our database schema?
Yeah, so for the final, because I do know that like we're at the end when we learn this, so I don't require it at all. The only constraints that I kind of expect you to have are primary and foreign key constraints, which, you know, like if your ERD is showing like the lines and stuff, they should be there. Um, so yeah, but as far as those other ones, yeah, I wouldn't worry about it because we're kind of hitting it super late. So if you don't have it in your schema, you know, don't worry about it.
I also have a question. As the same question as earlier. Whenever I run my schema, I saw there is some constraint and some constraint that were created on its own whenever I ran that.
Got it. Yeah. And if you have constraints, most of the time those constraints are probably because depending on which like options you check, let me see if I can find one. Let's open up this one. So like when we create like some constraints may be built depending on what we have checked here. So like this is a primary key constraint, a not null constraint. So for example, if I like if I'm not using the auto increment feature or trying to manually insert two of the same record, it would obviously throw an error on the primary key constraint. And so on and so forth. There's also unique in some of that stuff. So like if you have a unique constraint might be there or not null. And my guess is like most of the time, like when you see those constraints, it's not null. Or when you're trying to delete something, it might say, hey, you can't delete this because you have to delete it in reverse order of what you created it, which can get a little confusing. So depending on those, but if you want to shoot me over the error message you're getting, I can definitely help out with that.
Okay, thank you, no problem.
Yep. All right. Any other questions about indexes or constraints? All right. Okay. Well, we will shift gears just a little bit. And real quick, my fan just tipped over, so I'll go prop it back up real quick. So give me 1 second, and then we'll shift gears because what I want to do is cover a little bit of the final project deliverables and also kind of go over a little example of how we could build some of this. Just kind of do a little demo. So give me 1 second and we'll swap gears. All right. So final project. What I wanted to do is just real quick, one last time, kind of go over some of the deliverables and answer any questions around that. So let me get to there. Three and the final project. All right. So final project, we have our ERD, which I think everyone has pretty firm grasp of that. I don't think there's been many questions around that. The second is our CRUD statements, which we kind of gone over those before as well. But basically for every table, you're going to create four SQL statements. It's going to be an insert, a select statement, an update statement, and a delete statement. And the reason we do that is it's largely, it mimics an API, which is anytime we deal with like a database and an application, we can't really just like build on the database. Like there's this, like what we call middle layer. And most of the time we work through the database through an API. And so that's what those CRUD statements are for, because most APIs are solely built on CRUD statements, so that way you can pull. Basically, once you have a CRUD statement for every table, you can pretty much do everything you want once you have that API built around those CRUD statements. And we're actually going to kind of maybe cover some of this here in just a minute with our little thing. An index that maps user interface, CRUD test case, and SQL script files that support test cases. And so basically what this is, and this one kind of, so these are kind of all encompassing. So basically you're going to create a UI map, which is basically just like a wireframe. And for that wireframe, this is what I've gotten a lot of questions about, is like how much to show. Well, I would show like the consumer experience for the main kind of feature of your product. So for example, if I was going to do a web store, I would show, this is a page that shows like products and their information. And then the next wireframe might be, oh, I've clicked on the product and this shows like all the product detail. And then the next wireframe might be, oh, this is my cart and the items that I have in my cart. The next wireframe might be, oh, this is like a checkout window, so to speak. So that way it follows through the whole user experience. And with all those, you can label certain things, so that you can, basically we need to tie every bit of information or action that's powered by our database, with some SQL. So for example, back to our first wireframe, which is displaying all the products, we would likely have a select statement that says, oh, select the everything from product, left join, price, where product dot category is equal to bungee cords, something like that. And you can kind of make up things. Like, for example, if I'm just going to display bungee cords, like you can just kind of like put that in your query, or, whatever data you have. If I add something to my cart, that would likely, if I have like a add to cart button, I would need to label that and connect that with an insert statement, insert into cart with the relevant data. And, same with when I check out, insert into order with some fake data. So kind of just walk through those kinds of things. Now, some of those might already be CRUD statements that you've created in your CRUD, but some of them, so for example, like when we were talking about displaying all these products, likely we'll need to use like a couple different tables. So your select might have a left join. And so those probably won't be in your CRUD statements, but those will be kind of unique one-off SQL queries. And then finally, a PowerPoint presentation that kind of walks you through. So now the way I would describe this is, pretend that I am like an investor and you're trying to convince me to invest in your app. And as part of that, I not only want to like catch the vision of what your app's going to do, but I also want to make sure that like you have the relevant skills and have done your research to make sure it will work. And so what I would kind of do, and I think I posted this in Teams to a response, but basically I would start off with, I would have a slide one be like, oh, here's my project. This is what people are going to do. Then what I would do is I would walk them through, have like a slide for each one of your UI maps. And you don't need to necessarily show your code, more so just, hey, here's like where people will browse. Here's where they'll view product information. This is their cart. This is how they check out, that kind of thing. You can kind of just add relevant notes And then the last little bit, I would have, and you can add like little things like, basically just explain how the model works, how it's going to work. And like I said, there's no, at the beginning of this, I don't expect amazing things. So like if there's like a point you made a decision to do something, or or maybe you did something and you wish you would have done it differently, like highlight that, put that in there. And then the last couple slides, you can just do that. Like, is there anything you would have done differently planning wise? And then lastly, how did you like the project? What would you learn from the project, etc. And then you can be done. That's kind of how I would lay it out, but feel free to do your own spin on it. I'm not super particular about format or anything. That's more just to give you an idea of some ideas if you're need a little help in that direction. Does anyone have any questions about deliverables?
So our test cases include the CRUD statements as well as any one-off queries that we need to make the wireframe work well?
Yep, correct.
Okay.
Yep. Yeah, and so that's kind of like why I say start with your CRUD statements, because you need those for all 12 tables anyways. And some of those are likely going to be used for your UI map. But they shouldn't, if you're doing it right, you should also need some additional queries, because odds are you're going to have to query more than one table at some point, because that's the whole point of a relational database. So I would build your CRUD statements. Then I would like start mocking up the UI. And I think when I did it, like I would label each kind of UI portion with like and you can call it whatever you want, like TC1, TC2, test case 1, test case 2, and kind of put that in there. I think I also did like C1. So basically in your files, find some way, and that's why they call it a UI map. Quotes around the map is because it maps like user interface objects with specific sections of code, which, for example, like if you were going to run this to production, the nice thing is you guys acting as like the database engineers, is that, you've done this, and then you can hand this off to a web developer or a backend developer. Basically, you can pass it on down the chain, and there's really no question, because like they have a query, they can just replace like static values with variables. It becomes very easy for them. Everything's all laid out. They can just kind of build it. And when it comes to the database, all the queries are there. They can just kind of plug them in, which is nice. So that's kind of like the whole idea behind this, is like kind of getting to that point where as the database engineer, you're kind of like kicking the project off and then having it all ready to kind of hand off to other engineers.
Okay, so I have a question on what we were just talking about. I think most of what I have written has been test cases. So for the CRUD, do we just have to write like the simplest create, read, update, delete cases,
Yes.
and not necessarily ones that are being used in our wireframe map?
Yep. Basically, you have to have a CRUD for each table. So like if you already have some of those, you can just kind of copy those over.
Really fast question.
Yeah.
Sorry, this is a ERD diagram, right? This is like the ERD system that we need to have in place for the final, right? Just double verify.
So ERD is one of them. So like what's on my screen right now, this is a ERD. That's one deliverable. But then there's also a couple others. So like this is a start of my CRUD statements. And so for like each table, there's a create, read, update, and delete. And so, yeah, they can be just this simple. And as a little trick, if you need it, you can always come over to here. And like, if I wanted to take a look at my family cookbook, like I can right click on any one of these and kind of generate the structure of those queries. So for example, my system user, I can copy to clipboard. Here's my create, update, delete, and select all. So like, for example, if I wanted to check out my select all, there it is. So, like it's a little time consuming, but it's really just, nothing too complicated.
Okay. Sorry for interrupting the answer to the other question.
Nope. Yeah, they go hand in hand, I think. So yeah, for the CRUD statements, I would just keep it real simple. Like, so for me, I, do basic. The hardest one is when you insert data. And I use this to populate my test data. So like I kind of use this because I have to insert the data anyways, which you likely have already. Use those insert statements, because anytime you insert into a single table, that's your create, and so forth. So I kind of just went and did the bare minimum, like you said. Okay, any other final related questions?
So do we have to create a video or presenting the PowerPoint, or do we just submit like the PowerPoint along with the relevant files in like a zip folder and send it off to you?
Yep, exactly. So that's what I would do is I would just zip up the folder and submit it. So, I think I actually have an example here somewhere. New window.
So we don't have to worry about any video. We just zip and submit it.
Yep, no video. Just submit the PowerPoint.
Cool.
Where to go? There it is. Yeah, so like this is kind of like a sample of mine. And since you're zipping it, I would just include like anything you touch, which is basically what I've done. So, like if I was going to do my family cookbook, I have my UI map, I have my schema, my CRUD statements, I have my, I'm missing a couple things. But I would just throw this all in a folder and then zip it up and send it off. Cool. Good questions. All right, let's go ahead.
I have a couple of questions about the final, but I just don't want to like interrupt anything from this week material that you want to cover.
No, from here on out, we're just gonna kind of do a cool little, hopefully cool. It's cool to me. A fun demo just to kind of show, where the next steps would be.
Okay.
Because so go ahead and ask.
Okay. Well, I was just wondering, can I ask after you show us the cool demo?
Yeah.
Okay. Perfect.
Yep. So, anyways, let's do this demo. So basically what I've done, and I have a Git repository, just so you know, called Flask base. And this is kind of what I've started it on. There's a web framework called Flask. And like I said earlier, like, if we're using JavaScript, we can't really just like say, oh, I'm going to connect to the database and query the database in JavaScript. Like there has to be a server side kind of layer to this. And a lot of times those come in APIs because JavaScript can pull APIs. But again, you have to have something running those APIs. So what I really like about Flask is a Python-based web framework. And I'm hoping that most of you have seen or at least heard of Python at some point, so it's not too terribly complex. But I like it because it's really easy to spin up. It's super versatile. A lot of people use it for APIs. I've also seen it used a lot for, web pages and stuff like that. So that's what I'm going to use to kind of do this demo because it's what I'm familiar with and I really like it. So by default, this is kind of what this is running. It kind of displays this web page, which we'll come back to here in a minute. But basically what we're going to do is we're going to kind of build out a way to kind of look at our Sql database and maybe insert some information, at least query it, if we have time, we'll get to where we can actually see it or insert some data with like a web form. But we'll start with the basics. So anyways, this is my project. I have created this one file called Sql.py. And this is going to be kind of where I can build my, I guess the bulk of my kind of logic here. So the first thing I want to do is I want to register a route. And actually, I'm trying to think if we even need this or if we can just, let's just throw it in app.py actually. We'll keep it simple. So in Flask, what we do is we create a route, and a route is basically a web page, a URL. So you can see how like right now we're at root and it returns like a specific, it renders a template, which is home.html. You know, we can have it do all sorts of things. So like we can say, you know, / hello world. That's going to be our route. And I can define a Python function, you know, hello world, and say return. This is where I can just punch in some stuff and say hello world in HTML. So I'm going to save that. Let's hurry and run this. Flask. Run. So now if we go here, I can come up here and say hello world. And there we go. You know, so anyways, pretty simple, which is why I like it. And we're going to get more and more complex all the time, but for the most part, rather simple. I guess it's easy to parse. Like you don't need to know a whole ton. But anyways, one of the things that we want to do is we want to connect to My Sql, right? So what we need to do is we need to import a package that's going to let us connect. And that package is My Sql connector. So we're going to import My Sql connector. And there's lots of resources on this. Python connect to My Sql. Lots of resources on this, on how to kind of set this up. And lots of different ways you can set it up. So you can see they're using a different package. SQL, My Sql.connector. See if anyone's using the one we're using. There we go. So the first thing we need to do is we need to basically designate how we want to connect. So I like to give mine kind of like a name, and we're going to do this actually right. Let's define another one. So let's create another route, and I'm going to just say app.route, and I'm going to call this / Sequila / let's call it films. And we'll just say define show films. Cool. Now what we want to do is, for right now, I'm just going to say return not ready. So it doesn't freak out and say there's errors. But the first thing we want to do is we want to, like I said, connect to our database. So I'm just going to do this here. Normally we would do this kind of externally so it could be shared. But let's just do it. Actually, should we? Let's just do it here for now. Keep it simple. So what I'm going to call this is I'm just going to name this actually Sequila DB. And I'm going to set this equal to, and this is where we can build out our connection. So My Sql connector.connect. My Sql.connector.connect. And then this is where we can pass in our arguments. So in this case, we want to say that our host is equal to localhost because I'm running my database locally. Username, is it user or username? I always get a little confused. User. User is equal to my username. Password is School Rocks. And our database, oops, is equal to Sql. I believe that's it. Yep, cool. All right, so we're gonna just try this real quick. So what I'm gonna do is I'm just gonna have it print. So that's our database. So now what we need to do is we need to build a cursor. And the way we build a cursor is by just using a connection.cursor. And then from there, we can use that cursor to then execute things. So I'm just going to call this cur is equal to SakilaDB dot cursor. And then I'm going to say data is equal to cur dot execute. And then here we can just put our SQL, select everything from film. And now for the test, we're going to print data. I know right now we're not going to display anything. We're just going to simply call it for the most part. And we named this Sakila Films. So it says not ready, which is by design. And if we look, we actually got this none, which means that we didn't get any data. So we're missing something essentially. So let's see what we're missing. And oh, if we look here, we need to fetch our results. So that's what we were missing. So rather than say data is equal to cur.execute, we're just going to say cur.execute. And then data is equal to cur.fetch all. All right, let's try it now. Let's check our results. And what do you know? We have all this data coming through. Now, granted, it's not very clean and pretty, but that's what we're going to do now. So now that we know we have data, so inside this little data variable, we have everything from film, which is pretty cool, right? I think the minute that you can connect, especially with all the work you guys have done on your finals, you know, you've done all this work to compile this system, the database itself. It's cool to be able to build something to interact with it, even if it's just to view it, I think. So once you kind of get this connected, that's the hardest part, honestly, because now we can kind of do whatever we want with it, which is pretty cool. Because maybe what we want to do is let's build a class. So inside of our film data, let's just take this, delete it, use Sakila. So let's just select everything from film, which is exactly what we did there. But just to keep this process simple, I'm going to build a class that basically is just a film ID, the title, and the description, and the release year. So what I'm going to do is I'm going to say fine or class film. And I'm going to say, you know, it's got an film ID is equal to 0. And we're just going to build like a little constructor here. Film ID is equal to 0. Title is equal to an empty string. Description is equal to an empty string. And release year is equal to 1000. That way we kind of know that it's there. Define And apologies, I don't really know how to do like a constructor, so we're just gonna go with this film ID, title, description, release year. Self dot film ID is equal to film ID. There we go. So there's our little constructor. So now what we're going to do, basically we built this class so that way we can have like a model just to make this a little easier. So we have our data. So now what I want to do is I want to put this data inside of a class. Now there's little libraries that will help do this for you. So we're doing this a little bit of manually, but I think it'll make sense. For record in data, we're going to loop through and we're going to say, and that's a good question. How does this data come out? How did it look? Let's take a look. How did it look? It looks like a dictionary to me. Let's try it. So if it comes out as a dictionary, let's do for record and data. Let's just print. So we're going to take out this print data. We're going to print record as our first test. And then we're also going to print record film ID. Let's try it. Oh, error. So tuple indices must be integers or slices, not string. So one thing I'm going to do, My Sql connector Python dictionary. So we want this to come out as a dictionary. Dictionary equals true right there. So we just need this one little flag that says dictionary equals true. Perfect. There we go. So let's cancel our little temp server, refresh this time no errors, and this time we should get what we want. And in fact, I'm going to delete this so we can really see just our film IDs. And there we go. So all of our film IDs. Very cool. So perfect. So now that we are getting our data, now we can put it where we want it. So we're going to loop through every one of our records, which is each row, and we're going to create a class. So the first thing we want to do is we want to build all of our films. So films is equal to an empty array. And then for each time, I'm going to say new film is equal to a film. And I'm going to then assign some information. So new film, and I guess we can just put it all right here. Since we have our construct, let's do it the old fashioned way. So we're going to say, let's just call this a film to make it shorter. So I'm going to say a film dot film ID is equal to record film ID. A film dot title is equal to record title, and a film dot description is equal to record description. And you can see why the select as is important, because whatever we have here, our select as, is going to change what we put here in our stuff as the column name release year. And then, so that's our record. And then we're going to say films dot append a film. Cool. So there's all of our films, which is very, very cool. So now what we're going to do is we are going to, we're going to kind of take this to the next level. So the next step, now we have all of our data, and let's just, for film in films, just to check, we're going to print film. Just to make sure we're getting all of our data here. There we go, film objects, perfect. So now we're getting all of our data. So now the next step, we have all the data we need. Now we want to display it. And to do that, what we're going to do is we're going to go in here to our templates. And I have this base kind of dashboard, or we have like this home. Let's just take and copy. Let's just take and copy this home one. So I'm going to do is I'm just going to copy, and inside of dashboard, I'm going to paste. And I'm going to call this, I'm going to rename it. I'm just going to call this films.html. And what's cool is what I really like about Flask is this is called Jinja. And basically it's a way for us to really quickly spin out some HTML without too much work. So you can see here, I've predefined a bunch of HTML to kind of build this dashboard, but really what we want to do is we want to edit our content. So that's what I'm going to do here is I'm just going to change this from content goes here. We're going to call this films. And then what I'm going to do is I'm going to leverage some of this Jinja stuff. I'm going to create a little line. And then what I'm going to do is I'm going to just display a list of our films. So what I'm going to do is I'm going to build a table. And I'm going to build a table row, and this table row is going to have table headers. So we want the film ID. We want the title. We want the description. Actually, let's leave description off. And let's just go straight to release year. The reason I don't want description is because it can be really long. So we're going to do that. And then what's cool is, so now that we have our header rows, we need another table row. But what we want to do is, because we want a row for every record. So what we're going to do is we're going to use Jinja. And this is where Flask is pretty cool. So I'm going to say for film in films, that's my for loop. And then I'm just going to put another little curly brace and say end for. All right. So in here, we're going to do another table row, and we're going to do table data this time. And here we want to put film.film ID. And then another table data. And this one, we're going to do film.title. And then film.release year. All right, let's see how we did. So now that we did that, we're going to go back to our app.py. And instead of returning not ready, we're going to return render template. And this is where we can kind of put our template here. And our template is located at dashboard/films.html. And we want to pass some values. And we want to pass films is equal to films. So we're going to basically pass in a variable called films, which we referenced already for film and films. And we're going to give it our data from right here. So I'm actually going to take out this for loop because we don't need it anymore. We're going to save, and let's cross our fingers. And what do you know? Holy, there it is. Cool. So here is our table. You can see that we're pumping out all of our stuff minus like some minor CSS issues, which I'm sure we could fix, but you get the idea. So pretty cool. So now we're displaying information from our films, which is pretty neat. And just to show that it works, let's insert a new one. So I'm going to say insert into film, and let's do title, description, release year, language. What else is there? Oh wow, there's a bunch of stuff we didn't do. Rental duration. What's needed here? Let's take a look. Sql. And let's take a look at our film table. So not null. So we need a title, a language, rental duration, rental rate, replacement cost, and yep, that one's by default. So let's go back. Rental duration, rental rate, and I think that was it besides last update, which should be defaulted. So we're going to just go with that. Values. And what have we done? Values. FIFO goes west. Or sad little mouse. I don't know what year it was released. We're going to go with 1975. Language is 1. Rental duration is 3. Rental rate is $2.99. Unknown column language. Language ID, I believe. There we go. So now we have FIFO goes west. Now, because it's a little messy, I'm just going to change our select statement in here, and I'm going to say order by 1 descending. So order by the film ID descending. So I'm going to save that. Stop this, rerun it. And FIFO goes west should be right at the top of our list. Up, it's not. Did I do something wrong? Oh, because order by and I believe it's because FIFO goes west. Let's make sure it got in there, I guess. Oh, and it's because let's commit. There we go. Now we should see FIFO. There we go. FIFO goes west. I'm sure I'm butchering FIFO. But anyways, pretty cool. Forgot to commit. So there we go, because I did turn off auto commit after last week. So real quick, as one last little like part of this, because I don't think we'll get to where we're going to insert data necessarily. But what we can do is we can kind of do a cool little thing. We'll show you how we could see an individual. So app.route /Sql /films. And then we're going to have an int film ID. Right. So we have a show films. Now we're going to do a show film. And this time we're going to actually be able to show some individual stuff. So I'm actually going to reconnect this. let's do this. And instead of selecting film, we're going to select everything from film where film ID is equal to I think we need to do this dot film ID. There we go. Okay. So that is going to give us our select statement, and let's actually print that. Print. Let's just print this same string. And in this case, I think we can just fetch one. Fetch one. And then we can say film is equal to a film. And in this case, I'm actually just going to say film ID film. Well, let's do this. Let's just do it here. So we already have it. Whoops. We can get rid of that. And then turn render template, dashboard, and it's dashboard film.html. Film is equal to film. All right, so we're going to duplicate our films, but this time, instead of doing our for loop, we're just going to print our information. So we no longer need a table. And here, instead of saying films, we're going to say film dot title. Then we're going to say p film dot film ID jar, and then cool. So nice and simple. We'll keep it pretty simple just for the sake of this. So this time we're just going to get one record. Now in this case, we have this little thing going on here. What this allows us to do is actually put in a film ID. So in this case, 1002. So I can say, let's see, how did I define this? Films, yep. So now I can theoretically, let's make sure we stop this, do that. I can put in a / and what ours fivefold 1002. Oh, we had an error, so let's go check, fix that. And it is on right here. So let's see. It's because we have formatted this wrong. So let's see what we got going on here. This time. All right. So we stopped it. It ran. Oh, because we're just getting this %s here. So let's just try appending. That'll be a little easier. I'm doing this whole mess.
Is your problem possibly on line 57 where you have the template as dashboard.film?
No, it's definitely failing right here. So what I'm going to do instead of
Okay.
this is I'm just going to append it. So plus and then str. Oh, that actually could be exactly what. No, because we just did a double quote there. Let's just switch it to a single. All right. So then we're going to plus str film ID plus, and then we will have a quote or semicolon. This should do the trick. And oh, record. This is somewhere here. Because we have this as data, so let's call this record. That'll fix that. Perfect. And there we go. So now we can pass in any film ID here. Whoops, that is not what we wanted. Any film ID here. And we can change our films. So theoretically, now that we kind of have that set up, what we could do is back here in our films.html, I'm going to add one more column. And we're just going to leave it blank as header. And what we're going to do is we're going to add a little column here. And we're going to make a link. href is equal to. Now, there's lots of ways we can do this. There's a very specific way to do this with Flask, but just to show you kind of how easy this is, we can go to Sql films, and then here we're just going to punch in film.film ID. And VO. So now here, theoretically, we should have a little link. So if I want to see world leathernecks, I can click here and bam. We're starting to build a web app, which is kind of cool. But anyways, I've gone plenty over 20 minutes, actually. I hope this was at least somewhat interesting to kind of see. Because that's kind of the basic idea behind, why we're doing what we're doing and kind of the end result. Is so you can start to build something like this, and realistically the lift isn't quite that crazy. I mean, I know it may look a little complex, but really this is just basic HTML and some basic Python that pulls and puts the data into a class for us. But anyways, I've spoken long enough. I'm gonna let you guys go. If you have a question, stick around. If not, thanks for being here, and let me know if you have any troubles this week.
Thank you.
Yep, thank you.
Thank you.
Brother Crook, I do have a couple of questions. But if you want to stop the recording because it's gonna be pretty long,